In this video, we'll be solving three problems about hydrated salt solution, particularly solving concentrations of elemental composition and describing how to prepare this specific solution. So for number one, describe the preparation of 500 ml of 0.0740 molar chloride ion solution from solid BaCl₂ to H2O with the molar mass given 244.3 grams per mole. So as usual, this is same problem like the previous video, which will be linked above. So let's start from the final concentration. So it said that we have 0.0740 molar chloride ions. Molar is mole per liter, right? Now, let's put chloride ion here. So this is chloride ion. Now let's use the given volume to cancel the liter, right? So 500 ml is just 0.5 liters, okay? So that's just 0.5 liter. You can convert it, but just this, 500 ml. So 1000 ml is 1 liter. So that's just 0.500 liter, okay? So you can use this or you can just directly input 0.5 liter, okay? Now that you have the mole chloride ion, we can use stoichiometric coefficient from the solid BaCl₂ and the chloride ion. Okay, if you remember, in 1 mole of BaCl₂ to H2O, okay, we are asked here through dimensional analysis how many mole of chloride ion are there in BaCl₂ to H2O. So let's focus on the chloride, this one, right? So how many chloride? There are 2. So it requires 2 mole of Cl minus. Okay? So this means there are 2 Cl ions in 1 BaCl₂ to H2O. Okay? I hope you get that. Now we can cancel mole of chloride ion and we are left with mole of BaCl₂ to H2O. Now we want to know how to prepare this solution. Now we want to know the mass of BaCl₂ to H2O needed. Thus, let's use the molar mass given to get the gram unit. Okay, so 1 mole of BaCl₂ to H2O has a mass of 244.3 grams. Okay, and that would be 4.52 grams. So that is BaCl₂ to H2O. Okay, so that means we're going to start weighing 4.52 grams of BaCl₂ to H2O and then dilute it to its volume, thus creating 0.0740 molar. Okay, let's picture the method, okay, the proper method. So first, weigh, so from a result, weigh 4.52 grams of BaCl₂ to H2O. Okay, so you weigh that, then you should place it in a volumetric flask. So specifically 500 ml VF placed in a 500 ml VF. So VF is volumetric flask because we need to prepare 500 ml volume of 0.0740 molar. Now, the last step, dilute to mark. Okay, after diluting to mark, then since this is a calculated mass, you have prepared the 0.0740 molar. Okay, so that's how you describe the preparation of your chloride ion solution. Okay, so number 2, describe the preparation of 1 liter of 0.120 molar sulfate ion SO₄² minus solution from solid magnesium sulfate heptahydrate or MgSO₄ 7H2O with a molar mass 246.47 grams per mole. So as usual, let us start with the given concentration. Okay, and this time it's the concentration of the sulfate ion, which is 0.120 molar. So molar is mole per liter. Mole per liter. And now we focus on sulfate ion or SO₄ minus. Now let's use the given volume. So the given volume here is 1 liter. So this is simply put 1 liter. So that's easy, right? Then you can cancel the liter now. And let's use the stoichiometric coefficient. So 1 mole of MgSO₄ 7H2O. How many sulfate ion are there in 1 mole of magnesium sulfate heptahydrate? Okay, so let's focus on the sulfate ions. How many sulfate are there? So there are only what? 1, right? 1 mole of SO₄ minus. There is 1 mole of sulfate ion and 1 mole of magnesium sulfate heptahydrate because there's only 1 sulfate here. Okay, simply focusing here. Now, you can cancel the sulfate, mole sulfate, and we are left with 1 mole of magnesium sulfate heptahydrate. Then let's use the molar mass to obtain the gram unit. Okay, so that's 246.47 grams. So that's for 1 mole MgSO₄ 7H2O. Okay, you can cancel now the mole of magnesium sulfate heptahydrate and we are left with the grams. So calculating, we have 29.58 grams magnesium sulfate heptahydrate. Okay, so this is the mass of magnesium sulfate heptahydrate that you should prepare. Okay, so to describe the preparation, let's start with weighing. So weigh 29.58 grams MgSO₄. Okay. So if you are curious, uh, hydrated salts are solid. It is usually in a crystal form. So these are usually weighed using an analytical balance, right? So after weighing 29.58 grams, place it in what volume? 1 liters. Thus, you need to prepare 1 liter of sulfate ion solution. Okay, so place in a 1 liter or 1000 ml. So that's the same thing. 1000 ml volumetric flask. Okay. So after placing it, dilute to mark. Then you obtain 0.120 molar sulfate solution. Okay, so that's easy. So for the last question, so for number 3, this can be a practice for you guys. Describe the preparation of 250 ml of 0.0500 molar potassium ion solution using solid potassium phosphate with the molar mass 212.27 grams per mole. So as usual, let's start by looking the given concentration, which in this case is focus on potassium solution. potassium ion. And we need to prepare 0.0500 molar. Okay, let's start with that. 0.0500 mole potassium ion over liter. So mole per liter is just same with molar here. Let's use the given volume or the volume we need to prepare, which is 250 ml. And 250 ml is simply 0.250 liter. Okay, you can convert this, but I just directly converted it to liter. Okay, just remember 1000 ml is 1 liter. Okay. Then we can cancel liters and we're left with mole potassium ion. And now let's use the stoichiometric coefficient with 1 mole of the potassium phosphate. So this is the solute that we'll be using, K₃PO₄. Now we are asked with question, how many potassium ion are there in potassium phosphate? Okay, so potassium is K, right? So let's focus on the K. Okay, so how many K are there? So there are 3 mole of K. So 3 mole of K plus are there in 1 mole of K₃PO₄, right? So we can cancel now the mole of potassium ion. We're left with mole of potassium phosphate. Now we can use the molar mass of potassium phosphate, which 1 mole of K₃PO₄ is 212.27 grams. And we can now calculate, which is 0.884 grams K₃PO₄. So this is the amount that you must weigh in order to prepare the 0.0500 molar potassium ion solution. Okay, now let's describe how to prepare this. Okay, so as usual, let's start by weigh. Okay, what was our result? 0.884 grams potassium phosphate. Okay, after weighing that, place in a, so this time in a 250 ml, 250 ml volumetric flask, and then dilute to mark. So after diluting to mark, you have created the 0.0500 molar potassium ion solution. So that's it. That's how you prepare a elemental ion solution concentration from hydrated salts or from different solute. So for more chemistry problem videos, please support the channel and subscribe, or you can comment down below, ask what specific chemistry problems I should focus on next. And thank you for watching, and bye.